Hey there, folks. So, last episode we went through and added in the condition change, process condition change, and did some tweaks there. And I had ended things off, not quite having figured out how to do a blueprint override for this functionality. As I mentioned, trying to do this in a way for mod support that people can modify things via blueprints, modify things via C++ function overrides, things like that. And I genuinely don't know why sorry, I was looking at these errors. Didn't catch this at the time. It is a blueprint native event. That is what I was wanting to achieve. So for anyone who is not 100% sure, let me just see if I still have this open because I pulled it up to because I was going to work through it all, but apparently I've closed it now. So there's a blueprint native event and a blueprint implementable event. Now, the difference between those two is a blueprint implementable event is if the blueprint function isn't there, don't do anything. A blueprint native event is if the blueprint function isn't there, so in this case, process condition change. If that isn't there, fall back to the C++ version. I honestly don't know why I didn't think about that. That was... So having used that several times, I really don't know why I didn't know that one. But what I've done is I've gone through and I've tacked that on for the take condition damage and for the process condition change. I've added those in. And what this is going to allow us to do is we're going to have our C++ functionality, which we can override because it is a virtual void. That's going to allow any child class to override said functionality. And then we'll have the base one here, process condition change, which is going to be how you would override it in blueprints. So there is, however, one other function I want to add in here. This one I'm not going to... Actually, no, this one I do want to expose as well to blueprints as an override. So we're going to copy this here, the blueprint callable and the blueprint native event. This is going to be void adjust item condition. This is going to take a const float amount. And then I'm just going to copy this whole line, duplicate it, and add in that implementation to it as well. And then what we will do is create the definition for the implementation. And what this is going to be, it's pretty simple. It's going to be item condition equals fmath clamp item condition plus equals amount. We're going to have a minimum value of 0 and a maximum value of 100, and I want those to be floats. And just finish that off. And then the other thing we're going to want to do, obviously, is call process condition change. And the reason being for that, a good example that I can give is take a firearm. In some games, as the condition of that degrades, the likelihood of jamming goes up. The accuracy goes down. The damage goes down. So if you apply, say, a repair kit to it, you're going to want to recalculate, like, okay, is this we've bumped up to 99% condition, so our jam chance is going to go down to like 0.2% chance. Or a 2% chance, not 0.2, a 2% chance of jamming. Our accuracy is going to stay default. Okay, we've added a repair kit, it's bumped us up to 50%. Okay, so it's going to be a 10% chance of jamming, a minus 5 degree, or a 5 degree plus minus accuracy, however you intend to do it. I'm not quite sure how I want to do that yet, but that is something you could include and have within there. So you could also have things like, oh, well, this has been repaired back up to 100%. let's take it from this damaged item and make it a fully restored or a partially or a lower condition of this item. Things like that. So with that though, what I want to do is I do want to expand this slightly to sort of have a little better way of explaining just what I was talking about there. And you can see I've got a few things open here to go through. What I'm wanting to do is our clothing items. So that's going to be like body armor or coats or things like that. I want to have a way to adjust the information that is being information like the insulation value of your clothing or the protection value of your clothing based on its condition. So what I'm going to start with here though, I'm actually going to grab it from item base just so I don't have to type this all out. Copy that over. So I'm going to have a few different types of damage. There's going to be piercing damage, and I'm leaving these as 0 just to say there isn't any. There's going to be bludgeoning damage, slashing damage, so float, bludgeon, and I can't spell float apparently, and then float, slashing, and this is going to be for melee weapons. So this is going to be like, okay, if they're hitting you with a club, they're going to be doing bludgeoning damage. Slashing damage would be like a machete. Like they're hacking at you with a machete, or an axe would be a slashing damage. Well, axe would probably sort of be a mixture of the two. Or they're trying to like stab you with, say, a dagger or a rapier, like for fencing. That would be piercing damage. Or you get shot with an arrow. That's going to be piercing damage. You could extend this towards firearms, where firearms are all piercing damage, bludgeoning damage. I'm trying to think, like in my notes, I have this differentiated between like there's piercing, bludgeoning, slashing, and firearms. I'm not sure I want to actually keep the firearms one because again, you could have like a shotgun slug, which is going to be predominantly bludgeoning with some piercing damage. Actually, I think it would be piercing with some bludgeoning. For now, I'm not going to worry about the different damage type for firearms, but I do want to keep these basic types for at least all weapons, if not just melee weapons. But over and above that, we also have float cold insulation. Again, I can't spell float. And then finally, we have float heat insulation. And I can't spell that either, apparently. So I'm defaulting these to 0, simply because I want it to be, when you create an item, you have to go and add these in. You don't want to have to remove them. So like if you've got, say, a t-shirt, it's not going to add any piercing, bludgeoning, or slashing protection. It's going to add a little bit of cold, a little bit of heat. I don't want to have to go through, okay, I need to take off the piercing, take off the bludgeoning, take off the slashing, set those all to 0. I want them to be 0 by default so that they don't accidentally get forgotten about. In here, I'm going to leave the tooltips for, actually I'll do this right now. Piercing, damage, protection, copy that. If I could spell damage properly. I am not having a good day when it comes to typing on my keyboard. So let me just get these in place quick. So I had having enough trouble typing. I don't want to multitask too much. And then this would be cold. No, yeah, cold insulation. And heat. So these are very, like, they don't offer anything extra, but these are like, if you mouse over, you'll get the tooltip, and it gives things in a little more context, and you can always come through and expand on these. So in here, anyways, as I was saying, these are the basic piercing damage, bludgeoning damage, slashing damage, cold insulation, heat insulation. What you can do now is, well, from these, we have our, what did I put, where's condition? Our item condition. Now, this is a percentile, 100 to, oh, that was something else I did between episodes. I added in the clamp max on this. I didn't want it to go above 100 or below 0. So, because this is meant to be a percentile. Yes, we could treat this as a float from 0 to 1 as well if we wanted to. I'm going to be doing this for item condition. I want to do it from 0 to 100 because it gives you a slightly more wider range of being able to take condition damage. But anyway, so what we could do here is we could have our item condition, and going back to our clothing item, it's actually, let me open up Paint here, just because I want to do some really bad programmer art here. So you could have your item condition. Why am I using pen for that one? I can just, where, like, so this is, its condition is 100, and actually I'll type that in here. So your condition 100, condition 0. And at 100, it's going to return, we'll say, or sorry, how much of a percentile it returns, and then this is at 100%. And this is at 0%. So at 100%, we want it to return 100% of its condition value. At 0%, we want it to return 0% of its condition value. Now, we could have this quite literally just be a straight linear line there, which is perfectly fine. You don't need to, well, doing that, if you wanted to, it would quite literally be something along the lines of, let me just open up the code for this. I'm just going to do it here as a function. It'd be like return piercing damage protection divided by 100 times item condition. And that would be sort of how you would do that. If you want it to just be this straight linear, 100% returns 100% of the value. At 0%, it returns 0% of the value, so on and so forth. You could just do that. You wouldn't need to worry about adding in any additional logic or anything like that. Or, let's undo this, you could have it where it's more something like this, where it's got a sloped fall off, where it's not so bad, and then it drops down. Actually, I'm going to redo that line so it's more what I was aiming at there. So it would be something like this, where it's a slow degrade, and then once you hit about, say, 80%, it sort of drops down a lot quicker. If you're wanting to do that, you could use a float curve. So it's actually what I'm going to expand into on this one. So I'm going to just get rid of that for a second, clear this out. What we're going to want to do for our clothing item, though, for that, we're going to want to add in a couple of functions. U function, blueprint callable, blueprint pure, because we're not going to be making any code changes with that. So it's going to be a const float get cold insulation. I'm just going to duplicate this a couple of times because we've got cold, we've got heat, and then we're going to have piercing, slashing, and bludgeoning. Get piercing, protection. Get bludgeoning, protection, and you guys understand what I'm going to be setting up here, so I'm just going to do this real quick. Actually, I'll call heat and slashing. So these are going to be the functions that are going to return what is going to be ultimately, it's a negative multiplier. So again, just to try and explain that so you'll understand where I'm doing the code, we're going to have damage is 100. We have a 0.1% bludgeoning reduction. So what that is going to be is it's going to be damage times equals 1 minus 0.1 in this case. Throw that back so it doesn't. Not 0.1, not 0.1. So what that would be is it's times equal 90%. So it would be 90 ultimately. If bludgeoning protection was 1, it would be 1 minus 1, which means it's 100%. It just ignores it. So that is the methodology I'm going to be using. I'm not saying that's the best way. I'm just saying that's the way I'm going to be doing these. So I just wanted to get that explained quickly before I keep going forward with this. So we're also going to want up here another, where do we have those? That was in Chrono Manager. How did we define them? Lighting. Float curve. That's what they are. Yeah. I'm just throwing this include here in the header so I can go through and U-curve float. That's going to be class U-curve float. Protection. I'm trying to think how to word this one. Return. Fall off. No. Trying to think. Condition. No, trying to think. So it's trying to think how to describe this. Condition-based protection return. And those need to be a pointer. And just to cover that, that's here. Float curve used to determine percentile return of protection based on condition. All right, yeah, so with that, what we're going to do quickly here is we're going to just quickly create these various function declarations here. And then I'm going to fix up that include that doesn't need to be in the header. It's this one here, because it doesn't need to be in the header, and I know I've covered this before. The reason why you don't want to add includes to the header, if you don't have to, is then any other class that includes, in this case, clothing item base header, is going to load all of this in. Now, yes, you have pragma once. You have other ways to get around this, but it will help speed up compilation time, because even though float curve will say was included in equipable item base, when it gets in here, what will happen is it'll go, okay, I need to load float curve. It's going to open up the header file. It's going to go, oh, has this been defined? Yes, it has. Okay, we're done. Don't need to worry about it. It's not a drastic improvement, but again, when you're talking about hundreds and thousands of files, that include, it's a couple of milliseconds per include, but it adds up when you get there. So, or when you're talking about things on such a large scale. So, moving that over from the header to the source file, because that's where we need it. This one is going to be something along the lines of this. If, I forgot what we just called this now. Condition-based. How do we handle that in there for null pointer? Is valid. Okay. If not is valid. So if this isn't valid, what we're going to be doing is we are just going to return, as we mentioned, it's going to be piercing return piercing damage protection divided by 100 times by item condition. And this is basically, it's that linear fall off, like that straight line where if it's at 100%, we're going to return 100% of the piercing damage protection. If it's at 10%, we're going to return a 10% damage protection, or 10% of. If it is valid, what we're going to want to do here is float percentile equals condition based. How do we do that on these? Get float value. That was it. That's the wrong one. Condition based damage multiplier. Where did that one get pulled in from? Item condition. So you could do it this way, percentile. Now, for the purposes of debugging as you're going through, I would recommend this method here. So return percentile, because this way you can throw a breakpoint, you can see this, it's going to allow you to go, okay, we're getting this assignment and then we're returning this assignment. It's not efficient. What I would suggest you do is this instead. And then what that's going to do is it will, it saves some memory allocation. If, as you guys probably have seen throughout the series, it's one of the things I do try to explain and cover quite often is memory allocation. Because it's one thing I've seen with a lot of games recently, and including some for some like AAA studios, that you're looking at games that you need 32 gigs of RAM to play because it's consuming half of your system resources because they have poor memory allocation. And like I'm kind of shocked to see just how poor some of this memory allocation or memory management is being handled by some of these higher end studios. Because like I don't have an amazing system. I don't have a bad system either, but I've been playing some games recently that my memory allocation is going through the roof. Now there's some games I've been playing from like indie studios, which I wouldn't say I make exceptions for that, but I sort of expect that because these aren't multi-billion dollar studios that can afford to hire someone who understands memory management. So, anyways, that little diatribe out of the way, let's go through, and I'm just going to copy and paste this through all of these and quickly fix them for the particular variable that they're returning. So, piercing protection is done. So we want bludgeoning damage protection. Let's copy that. Easier that way. Piercing, bludgeoning. And I realize I've got a typo here. A bug. This is a clear bug. So condition-based protection return. This is going to get like a 90%. We don't want a 90%. What we want, and I'll fix it here, is we want piercing, or in this case bludgeoning damage times by this. We want piercing protection damage times by this, because this is going to give us our percentile. We want a percentile of this. So anyway, so this is slashing. Let's fix that up quickly. Now you could also expand this to have different float curves that, okay, say I'm trying to think of a good example. A ceramic vest, like ceramic plate bulletproof vest. They really can only take one, depending how the plates are set up, 1 or 2 shots before the ceramic plates are just destroyed. But they would still offer some other protection. Like they would still offer some good slashing protection, some decent piercing protection. So their condition would be different based on, this modification would be different based on particular type of damage being done. So you could expand this to be the piercing condition-based protection return, bludgeoning-based condition-based slashing, cold, heat. You could separate these into the 5 separate ones if you wanted to. If you were going that route, I would recommend having, like we did with our chrono manager, instead of having a float curve, use a linear color curve, because that gives you 4. You have their red, green, blue, and alpha. So you have 4 separate curves stored within one data object. So then you could cover, say, your piercing, bludgeoning, and slashing in like the red, green, blue, and then say you just want a general like alpha for cold and heat. So you could do that as well. For now, I'm just going to leave this as a singular float curve used for all of it. That could be the case. That may be something we expand on in the future. Like I want to create that ceramic plate bulletproof vest that it will take the first time it's got piercing or bludgeoning, like basically it's taking a gunshot, its protection in a couple of other areas are completely removed. Like it's not going to take a second bullet, but it's still going to offer you some heat insulation. It's still going to offer you some cold insulation, and it's still going to offer you slashing protection. That sort of thing. So I may expand that and add that in as an extended child class, because that is something you would need to think about with your project, because that's increasing the data allocation for every item that is of that class. So anyway, so let's just finish this up here. So we've got that. If the this is going to be our cold insulation. Helps if I add my spaces in there. And our heat insulation. Now, with this, what I am going to be doing is I'm going to actually end the episode off after this, but what we will be doing is we're going to continue working on this section of the code. We're going to, and by that I mean we're going to go through and working on like our cold and heat insulation values. We're going to go through and get those hooked up in a way that they're going to be able to be used here within our stat line component. And that's going to involve our inventory component, obviously, because that's going to be where the logic is called for equipping and unequipping things. So this will basically be a case of, okay, we're going to equip an item. We're going to need to call back to here, owner, which is a TF character class. So we'll go to this function here. Right now it's just slot and the item mesh. That's fine. We don't want to change this function because this is for skeletal mesh assets on the character. We're going to want to go through though and obviously make some changes to add insulation, remove insulation, things like that. And then something I'm still working on in the design aspect is how we're going to be leveraging the protection values. Obviously, that's something we'll be dealing with a little later in the series. We've done some basic things there, like the wolf will bite you and it'll hurt, but we need to address that, obviously. But before I end the episode off, though, we are going to just do a quick build. I want to make sure I haven't exploded the code in any way, caused any like compilation errors there. But with that, as I said, next episode we will be going through covering how to address. Well, not how to address, how to pass this through. So pass through the heat insulation, pass through the cold insulation, and then also how we're going to want to modify that given an item's taken damage. So you're wearing a winter coat and something attacks you, bites that winter coat and destroys, like rips the arm off, for lack of a better description. Causing like 50% damage reduction or condition reduction. We're going to want to be able to then pass that back to our stat line component and say, update, reset these values. And we're going to want to figure out how we're going to do that as well. And that is something that's going to take a bit of planning on my side. Simply because the way I have implemented this is we've got the let's just go file new here. Build succeeded. Anyways, just quickly though, before I end the episode, because way we've got this set up is we have our. So I'm just trying to find it. Our character. We've got our inventory component. Change there. We've got our stat line. And what we're having to do with these is we're having to sort of have these, I can't even draw arrows in this paint. Trying to get this drawn really poorly. What we're needing to do with that, okay, got that, let's go there. We're needing to sort of get communications going like this, back and forth. Our inventory component is going to be the owner of the clothing, like the equipped clothing. We need it to be able to say, okay, stat line, we've lost some cold insulation. Or stat line, we've lost some heat insulation. Or stat line, we've gained some cold, we've gained some heat, depending. And what that'll do is that what that means is we need to have this communication channel, or we need to have pointers where we've got, okay, the inventory component goes, okay, player character, what's your stat line component? Do you have one? Okay, if you do, I'm going to have to worry about talking to it. And that is probably the way I'm going to do it, because the way that works is on begin play, this will go, here's my stat line, and it'll hold a reference to the stat line up here, and it'll just talk like this. Doesn't need to do that pass through. So what that would be, inventory component header. No, that's the source file. So in here you can see we don't have a pointer to that. We have a pointer to the character. And the reason why I need to decide exactly how I want to do this is I also sort of don't want classes to know about too many other classes. Like really, I just want the inventory component to worry about knowing about its owner. So I've got to decide, do I want it to talk to the owner talks to its stat line, or do I want it to have that pointer? And this is something you will want to decide with your project, either by yourself, if it's just you, or your team, on how you guys want to go about that. The reason why I don't want, well, I'm trying to avoid classes knowing about too many other classes is, again, for that modding support. Like, if the inventory component only knows about the owner, then your TF character class and your inventory component class, if you need to make changes for modifications, well, you only have to worry about those two classes. You don't have to worry about, oh, I made changes in my inventory and in my character class. I also need to go work on the stat line component or the chrono manager. So like that's the whole purpose for doing things that way. So, but anyways, folks, I sort of rattled on this last like 8 minutes. I'm going to end things here. As always, if you do have any comments, questions, concerns, suggestions, please feel free to leave them in the comments below. Hop over onto the Discord. There's been a lot more activity on there recently. It's been nice to see. But as always, folks, thank you for watching, and I will see you in the next episode.